Now let's move on to recurring decimals. So for those who don't know what these recurring decimals are those decimals that keep on repeating itself after the decimal point. So things like 1.8, and the recurring decimal will be notified by a little dot on top of the number. Okay, so if it looks like that, that is basically 1.8888 on forever and ever. Okay, that's a recurring decimal. And I'll give you another little example. Say for example, if you have 1.23, say for example, and you've got two dots on top of the two numbers, that means both numbers are recurring. So it's going to be 1.232323 on forever, infinitely. Okay, so that's what it is. And one more, say for example, I don't know, I'm just making these up, but if you have something like this, and you have two dots, but not on top of the three, but on the other two numbers, that means all three are recurring. We don't write it like this. Okay, so we don't write like that. If all three are recurring, we just write like this on top of the outer two numbers, and that will look like 1.234, 234, 234, etc., etc., on and on forever. Okay, so that's our recurring decimals. Hopefully a lot of you do know this anyway. Let's get started with question 8. Write these fractions as recurring decimals. Now in this part, I just want you to have a calculator handy, guys, and put that into your calculator. Okay, so try to put that into your calculator using your fraction key, and you should get something like this. So which one is the recurring number? Is 8 recurring? No. Only the 3 is recurring, so we simply put the dot on top of the 3. So we leave the 8 and we just put the dot on top of the 3. That's all you need to do. Now B, again, trying to put that into your calculator, guys, and see what appears on your screen. You should get something like this. Now guys, tell me which two or how many of them are recurring. You can see that 1, 3, 1, 3, 1, 3. So both numbers 1 and 3 are recurring. So you simply need to put the dots on top of both numbers because both of them are recurring. And another one, put that into your calculator, guys, and check what's on your screen. You should get something like this. We've got 0, 0, then we've got 587, 587, 587, which means these three numbers after the 0, 0 are recurring. So all three numbers are recurring. And guys, do you remember what I said about the three numbers recurring? I said you simply need to put the decimal on top of the outer two numbers only. You don't have to put dots on top of the 3. If you put a dot on top of the 8, you lose your mark. So that a little dot makes a difference. So that's the answer. Okay, and the 0, 0, make sure you don't forget about that as well. Question 9, express the following as a fraction in its lowest term. Okay, this time we have to do some working out. You can see that the dot's on top of the 1, which means that that's going to be 0.111, etc., etc. Now what I'm going to do is use a bit of algebra. So I'm going to let that one be x. Okay, I'm going to let my original recurring decimal as x. So see how I let 0.111 be x? Now what I'm going to do, this is the trick, watch very carefully. I'm going to multiply that one by 10. So this side becomes 10x, and this side, the decimal would move towards the right by 1, so it becomes 1.11111. It's still recurring, isn't it? Now here's a trick again, have a look. What I'm going to do is subtract. Subtract 10x minus x. So subtract the first one from the second one. So it's going to be 10x minus x, and this side as well, we just subtract 1.1111 minus the 0.111. Now see what I have. What's 10x minus x? It's 9x. And see here, if I put it under each other, see how I have 1 on the right hand side? Have a look. This one, which is 1.111, etc. And this one is 0.111, etc. And if I do some subtraction, you can see that all of these ones cancel out. And all of these future ones will also cancel out. And then 1 minus 0 is just 1, so we just have 1 left. Okay, so this is the idea, to eliminate anything that's recurring, and that's why we have just 1. So what's x? Simply divide both sides by 9 and we get 1 over 9. That is x in its lowest term. Okay, so we can't simplify any further. And that's it. So 0.1 recurring is as a fraction 1.9. And if you have a calculator handy, you can always check your answer. So this question you should get always full marks because you can always check your answer. So put that into your calculator and change it to a decimal and see if it's the same as that. And if you did, that means you've got the right answer. Okay, so how cool is that? You can check your answer. Now B, we'll do the same kind of thing. Okay, so you guys can try if you like, or otherwise watch. So this time we've got an extra 0, but we still have dot on top of the 1, which means it's going to look like 0.0 and then 111, same as before. Now I'm going to let the original one be x, so that becomes x. Now what I'll do this time is multiply by 10, like we did in the previous one. So we get 10x equals 2. See how I move the decimal towards the right by 1? So we have 0.111 like that. Now, if I think about it, guys, if I subtract that from that, I still get a decimal. I don't want to have a decimal anymore. So what I'm going to do is try to do another one. I'm going to try multiplying by 100 this time. So multiply that one by 100, you get 100x, and this one will move to the right by 2 places. So 1, 2. So we have 1.1111. Okay, now consider these two numbers. So you're trying to ignore the top one now. Let's work with these two. If I do 100x minus 10x, then I'll have to do 1.111 minus 0.111. And you can see that 100x minus 10x is 90x. And you can see that this part, all the ones after the decimal will cancel out, and we only have 1 minus 0 left, which is 1. So we don't have any more decimals remaining. So we're going to do the exact same thing, just solve for x. X will be 1 over 90, and that's your answer as a fraction. Again, you can check your answer, guys. Put that in your calculator, and you should get something like this appearing on your screen. Okay, so sometimes you might have to do another step. So you might not just be working with the 10x and the x. Okay, so that's the thing I want you to be aware of. See? Okay, we've got 2 recurring numbers, 1 and 2. So it's going to look like 1, 2, 1, 2, 1, 2, like that. So that's going to be x. Now we'll do the same thing multiplied by 100. Because I'm not going to do 10. For those who can catch it pretty quickly, I'm multiplying by 100 straight away because there's 2 numbers recurring. So if I multiply by 100, the 12 will go behind the decimal, and again after the decimal we'll have 1, 2, 1, 2, 1, 2. The idea is to have the same numbers after the decimal point, so then when I subtract, everything will be eliminated. That's why I'm multiplying by 100. If I do it by 10, I'll probably get 2, 1, 2, 1, 2, 1, and they will never eliminate. Okay, so now we'll do the subtraction. So 100x minus x, and then the 12 point minus the 0 point. And you can see that after the decimal, everything is the same, so they will cancel out when I subtract. So we'll just have 100x minus x, which is 99x, and 12 minus 0, which is just 12. Okay, and then divide both sides by 99, we get 12 over 99. But guys, I think we can simplify further. We have common factors, don't we? So simplify both by 3, and then we get 4 on 33. So make sure it's in its lowest term, simplest form. Okay, and that's it. So it's pretty repetitive, isn't it? D, again, it's very similar, but we just got that extra 0 at the front. So we'll try the similar thing. So you can see that the 1 and 2 are repeating, just like that. So that's what's going to be x. This time, I'm going to multiply by 10, because if I multiply by 10, I get 0.121212, which is exactly the same as what we had in the previous question. So by multiplying by 10, I can eliminate that extra annoying 0. So it looks like the normal recurring decimal that we had in the previous question. Now, multiply by 1,000, and I'm not going to multiply by 100, I'm multiplying by 2 extra zeros, 1,000, because by doing that, I'll move 2 places to the right, and I'll again have 1, 2, 1, 2, 1, 2 after the decimal point. If I multiply it by 100, I'll have 2, 1, 2, 1, 2, 1, and they won't eliminate. Get the idea? So now we'll just work with these two. So 1,000x minus 10x, which makes on the right hand side 12.12 minus the 0.12. And they have same numbers after the decimal point, so all of these will cancel. And we'll just have the 12 minus the 0, which makes 12. And this side is 990x. Again, divide both sides by 990, divide by the common factor, and you should get 2 over 165. So the last part is pretty simple, but that's the idea. Again, put that into your calculator and check if you get the same answer as the original one. Always check, okay? It should only take a couple of seconds. Alright, so this time it's getting a bit more challenging because we have 3 numbers recurring. Remember, if the 2 outer numbers have the dots on them, all 3 are recurring, like that. 231, 231, etc., etc. That's what's going to be x. So this time, what do you think we should multiply by? Do you guys want to have a good educated guess? This time it should be 1,000 straight away, not 10 or 100, because 3 numbers are recurring. So if I multiply by the 3 zeros, so the 1,000, again we'll have 231, 231 after the decimal point. So then we can just subtract these two. So 1,000x minus x, and then the 231 minus the 0 point. So you can see the numbers after the decimal point are the same, cross them out like that. Okay, you can put them under each other if you like. And then therefore we just have 231 minus the 0, so that will make 231, and 999x on the left. So divide both sides by 999 and just simplify if you can. Okay, just by 3, because that's the common factor. And again, just check your answer in your calculator. Okay, this time, only the 2 and 3 are recurring, right? Not the 1, don't get confused, alright? So it's just going to look like that. So we have 0.01 as it is, and 232323 is recurring. So that's x. What should we multiply this time? Multiply by this time? Well, this time what I'm going to do is multiply by 100 so I can eliminate these 2 numbers out of the way. Because if I multiply by 100, I'll move 2 places to the right, and I'll just have 1 before the decimal. And after the decimal, we'll just have the recurring numbers, 2 and 3. Okay, so no more annoying little bits in between. So now I want to multiply again so I can do some elimination. What should we multiply by? As you can see, 2 numbers are recurring, so we have to multiply by an extra 2 zeros, so 10,000. Okay, so see how we added 2 extra zeros from the 100? Because we want 2 places to go to the left of the decimal. So now we have 123.232323 again. Alright, so we have same numbers after the decimal point. So we're just going to work with these 2. So subtract them. So that minus that, and this minus this on the right. So because it's all the same after the decimal, cross it out. So we just have 123 and 1 on the left, on the right. So 10,000 minus 100 becomes something like that, and 123 minus 1 is 122. Just put it over each other so we can just solve for x and always simplify by a common factor. And that will be your answer. Make sure you can check that into your calculator, put that into your calculator and see if you get the same number as we had in the original question. Okay, and that's it. That's the answer as a fraction in its lowest term. So the idea, hopefully you get the idea already because we've been doing the same thing over the past few questions. But guys, this one needs a lot of practice. You won't get enough idea unless you try it yourself. Okay, so I want you to try at least 10 of these questions on your own to get the right idea, you know what? And then you get full marks for your working out. So always try the practice questions following.